Hello dear students, today the topic of the class is open loop op-amp configuration. There are three configurations in open loop. The other name of open loop is without feedback. The three configuration names are the differential amplifier configuration, inverting configuration and non-inverting configuration. In these three amplifiers configuration mode, you will be learning about what is the output equations in each configuration. In this class, you will be learning to write the output voltage equation of differential amplifier configuration, inverting amplifier and non-inverting amplifier. So let us start with the three configurations of open loop op-amp. The first one is differential amplifier. Differential amplifier means the op-amp amplifies the difference between the two input signals. So this configuration got the name as differential amplifier. Here the two inputs are V in 1 and V in 2. The amplifier will amplify the difference between the two input voltages applied. What is the basic op-amp equation? V0 is equal to A times of VID. VID is the difference input voltage which is equal to V1 minus V2. So what is output voltage equation? V0 is equal to A times of V1 minus V2. What is V1 value? Voltage V in 1. V2 value is V in 2. So we have substituted V1 as V in 1 and V2 as V in 2. So we get the output voltage equation of the differential amplifier in open loop as V0 is equal to A times of V in 1 minus V in 2. The op-amp is a versatile device because it amplifies both AC and DC input signals. This means that V in 1 and V in 2 could either be AC or DC voltages. So what is a differential amplifier? It amplifies the difference between the two input signals. Coming to the second configuration, inverting amplifier. So if you look at the differential amplifier, it is having two inputs, V in 1 and V in 2. Coming to inverting amplifier, it is a single input amplifier. Input is applied at the minus or inverting terminal of the op-amp and non-inverting terminal is grounded. The op-amp basic equation is V0 is equal to A times of VID. VID is equal to V1 minus V2. So V0 is written as A times of V1 minus V2. V1 is how much? As its ground, V1 will be 0. V2 will be equal to V in. So we have substituted V1 as 0, V2 as V in. On simplifying, we will get V0 is equal to minus A times of V in. The inverting output voltage equation is V0 is equal to minus A times of V in. The inverting amplifier amplifies the input signal by gain capital A and is inverted at the output. In inverting amplifier, only one input is applied at the inverting input and non-inverting input terminal is grounded. The negative sign indicates that input voltage and output voltage are 180 degree out of phase with respect to each other. Coming to the third configuration, non-inverting amplifier. In non-inverting amplifier, the input is applied at plus terminal or non-inverting terminal of the op-amp and inverting terminal is grounded. Op-amp basic equation is V0 is equal to A times of VID and VID is a difference input voltage, so which is written as V0 is equal to A times of V1 minus V2. Which is equal to, what is V1 value? V1 is V in and V2 is 0 because it is connected to ground. V1 is V in, V2 is 0. So we get V0 is equal to A times of V in. So this non-inverting amplifier configuration is also single input amplifier. In non-inverting amplifier, output voltage is larger than the input voltage by gain A and is in phase with the input signal. Input is applied to the non-inverting terminal and inverting input terminal is grounded. I hope the class is clear. In this class, you have understood about 3 open loop configurations: differential amplifier, V0 is equal to A times of V in 1 minus V in 2, inverting amplifier, output voltage is equal to V0 is equal to minus A times of V in, non-inverting amplifier where V0 is equal to A times of V in. You can post your queries in the comments section. Thank you for watching. Good luck, students.